Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science, MLR Institute of Technology, Hyderabad. Today, I have come up with another video on subject called Stream Processing and Analytics. Today, we are going to discuss the information systems. Okay, so let's move on to the overview of today's presentation. I have divided my overview in multiple parts. As the first part, we are going to discuss what is an event. Okay, so next we are going to discuss what is an information systems, which is our main topic name. And next I will discuss stream processing, and next I'll tell you what is batch and what is stream processing, and next we'll discuss about data forms, multiple data forms. Finally, I would like to tell you what are the timelines which are related to stream processing. Okay, as a part of our first topic, let's move on to the first topic. What is an event? Okay, here event is nothing but any digital interaction. Okay, any digital interaction. Okay, in 2011, Mark Andreessen famously said that software is eating the world. What does it mean? Okay, it means that booming the digital economy or booming the digital interactions or digital transactions. Okay, in nowadays everything is transformed as digital, right? So he said that software is eating the world, which means that everything is digitalized these days. Okay, at a time, in the same time, many companies were facing the challenges of a digital transformations. Okay, if any company moves towards the digital transformation, those companies are facing the challenges, because to handle those kind of data is very difficult, right? So each of our digital interactions, like searching for keywords on the web. Okay, if we can take a website or any internet as an example, if you search for any keyword on the internet, it will be considered as a one event. Okay, clicking on some links on any web page, if you click on any links, it will be also considered as a one event. Okay, spending time reading a particular page or web page. Okay, spending time to read any web page or page is also considered as an event. So those are called as series of events that are collected and transformed into business value. Those events are collected by the business people and they are transformed that events into money, which means that whatever you are searching on the internet, they are making it as a business. Okay, so some popular online searchings are in our daily life. If we take what are the searching, popular searching events are nothing but we go through the news and current events daily, right? So that is also one kind of event. Weather updates, sports events, which are mostly these days many people are interested in sports, right? And travel information related to some places, and next shopping. Whenever we have any special occasions, many people will search for shopping, right? So that is also considered as an event. And social media platforms and entertainment, these are the main parts of our daily routine. Okay, all these are considered as an event, and many business people are making these as a money. Okay, if you can observe here, as an example, I have taken bank transactions as an example. Okay, these days bank transactions are digitalized, right? So here, if you can observe that there are multiple stages from where we can take the money. Okay, now let's move on to the second part. Okay, what is an information system? So our information systems are built on hardware. Okay, what is the information system? Whatever the data we are collecting, those data are gathered on any hardware, which are finite sources. Which are finite means which have some proper size or proper design or structure, as memory. If you all know that what is a memory and storage capacity. Okay, some storage devices, they cannot possibly hold unbounded data sets. Okay, these finite resources or these memory storages cannot store unbounded data. First of all, we are going to discuss what is unbounded data. If we can categorize data into two types, the first type is bounded data, the second thing is that unbounded data. Okay, unbounded data. So if we discuss bounded data is nothing but it is a known size data set. Okay, bounded data is nothing but data set of known size. We can count the number of elements in bounded data sets. Okay, this we can call it as a bounded data set. Okay, we can count the number of elements, how many elements are there in a bounded data sets. Vice versa, on the other hand, bounded data set is one kind of data category, and on the other hand, unbounded data, a type of data set which is infinite in size. We cannot measure the size of the unbounded data. The data received at the processing system, okay, it will receive at the processing system in the form of a flow of events, okay, in the form of events. Every event is considered as a, every event is considered as a unbounded data in a form of events over time. We can call this as a stream of data, as our subject name suggests, that stream of data, okay. This flow of events are nothing but stream of data, okay. So these are two main differences between bounded data and unbounded data, okay. Now let's move on to the next topic. What is stream processing and how it is related to our unbounded nature, okay. Stream processing is a discipline and related set of techniques used to extract the information from unbounded data. As I have told you just now, unbounded is infinite in size and which are flow of events, okay, from the processing systems, okay. So stream processing is nothing but to extract the information from that kind of unbounded data sets. So especially here, Apache Spark is the main important or crucial data processing framework we use here to process the stream of data or stream of events, okay. So which can handle the requirements of batch and stream workloads, okay. If we can divide workloads in categories, we can tell as workloads, we can tell as batch and stream, okay. What is batch, what is stream, I'll tell you in the coming slide, okay. So Apache Spark has ability to handle both batch as well as stream processing workloads using a unified model. Unified model is nothing but it has every skills or tools required to handle this kind of stream data. Apache Spark is fast, okay. What is the main characteristics of Apache Spark? It is fast, general purpose distributed computing system. It is a general purpose. We can use for multiple things, not only for one particular thing. We can use it as a multiple purpose or general purpose. Distributed computing system. What does it mean? The data or workload is distributed among multiple systems and those systems will work individually to complete this particular process, okay. So that is nothing but distributed system. All the systems works in a distributed or parallel manner. For big data processing and analysis, okay, these systems process for big data analysis, okay. It is known for its speed, okay. As I have told you that Apache Spark is very speed, which is more 100% faster than BDT, and scalability, ability to handle various workloads, okay. As I have told you that workloads may be divided into multiple categories including batch processing, okay, it may be batch processing, real-time analytics, which are flow of events in the real time, or machine learning, and graph processing, okay. Not only for one type of workload, it will handle various kinds of workloads to process the data, okay. So here I am connecting stream with a unbounded, connecting stream with unbounded data sets, okay. So far we have learnt that how stream processing is related to unbounded data and what is an event, okay. Now I would like to tell you the next process. So here, as a part of previous slide, what is batch and what is stream processing? First of all, we are going to discuss what are the difference between these two words, okay. What is batch processing? How do we process both types of data sets, okay. What are those data types? Unbounded and bounded, okay. So with the batch processing, we refer to the computational analysis of bounded data sets, okay. Batch processing works with a bounded data sets, okay. As the name suggests, batch is nothing but data is divided as multiple batches. Based on some time, those batches are go for processing engine, okay. This means that those data sets are available and retrievable as a whole from some form of storage, okay. We can collectively calls or we can collectively store these kind of batch processing data sets. we know the size of the data sets, because why we can store easily means we know the size of the data set and we also know the computational processes. And at the start of the computational process, the duration of the process is limited in time. Okay, as we know the size of the data, so the time also we can measure, right, easily, because based on the size of the data we can measure this process can take this much time and the next batch can take this much time. So here these two are related to each other. In contrast, with stream processing, we are concerned with the processing of data as it arrives to the system. Okay, here in contrast, batch processing we are storing on some any finite devices and we are processing it, but when it comes to stream processing there is no storage devices. When the data comes into the system, at the same time, in the given time, we are going to process that kind of data which is in unbounded in nature. Okay, given the unbounded nature of the data streams, the stream processors needs to run constantly. The processors of the stream has to run constantly because they are not storing any data. Immediately they have to get the insights as long as stream is delivering new data. Okay, if suppose data processing systems are ready to take the data, they will those systems continuously take the data from the stream of events and automatically to the onto the spot they will get the output or insights. Stream processing systems apply programming and operational techniques. These systems apply programming and operational techniques to make possible the processing of potentially infinite data streams with a limited amount of computer resources. Okay, so this processing system can take the limited amount of data structures or next computational sources and they will potentially process the infinite data streams. Those are not finite in nature. Okay, so this is the main difference between batch processing and stream processing. Okay, batch processing is mainly related to bounded data, whereas stream processing is related to unbounded data. Okay, now let's move on to the next topic. What is data form? Okay, next, the idea of time in stream processing. Here previously we have learnt about what are the types of data. Here the time here when comes to stream processing, what is a time which is helpful in stream processing to get the analysis. Data can be encountered in two forms. Okay, with respect to time, we can divide the data into two forms. The first one is at rest. Okay, the data on a particular time, the data which is at rest in the form of a file. Okay, that data is not moving. The data is particularly stored on any devices like file, contents of a database or some other kinds of record. We can store them on any particular storage devices. Next, the second type of data is data in motion. Okay, as a continuously generated sequence of signals, like the measurement of sensors or GPS signals from moving vehicles. If we can take example in motion, data in motion, here we can take GPS or sensor signals as an example. Those data are continuously generated from some sensor devices or GPS signals from moving vehicles. That kind of data we can call it as a data in motion. Okay, data at rest is data from the past. Okay, if we can call data at rest is a past data which we have collected from some databases or some file systems. All bounded data sets. Bounded data sets, just now we have completed this topic. Bounded means which is in finite in size and we can measure the contents of the elements, whether stored in files or contained in databases, where initially a stream of data collected over time into some storage devices. Okay, this kind of data at rest we can store on some devices. The user's database, all our orders in a month, the GPS coordinates of taxi trips in a city and so on to start as an individual event. Okay, these things are, we can call it as an individual events. Data in motion is more challenging. Okay, when compared with data at rest, okay, dealing with data in motion is little challenging. Why? Because we can store the data which is at rest position with respect to time on any devices or storages, but the data which is in motion we cannot hold those values on any particular storage devices. We have to handle in a simultaneously, which when the data arrives into the processing systems. Okay, so these are the two types of data with related to time constraint in stream processing. Now let's move on to the next topic. Okay, here the word itself says that this is related to time. Okay, timelines. There is a time difference between the moment a data is originally generated and when it becomes available for processing. Okay, if we consider an example, suppose I have searched for any web page. Okay, the time which I have started opening the website is the time of the event started when the website connects to the when the website connects its database. This is the processing time. So there is a time difference between the data, the generated data, and the data which at the data is processed. Okay, that is nothing but timelines. Okay, we can observe that there is a timeline when the event was produced. Okay, when the event was produced, another for when the events are handled by the stream processing system. Okay, when there is a timeline difference between the data is generation and data is processed with respect to stream processing. These timelines are so significant. Okay, why these timelines are significant means, if we want to aggregate any multiple events at a time, we need the timelines or any specified times related to each and every individual event. For those kind of aggregations, we require this kind of timelines. These timelines are so significant that we give them specific names. Okay, based on the data and based on the times, we can give some specific names. So with respect to time, the data which is processing with respect to time, we can divide them in as a two types. One is event time, second one is processing time. So what does event time means? The time when the event was created. As I have told you that we have multiple events encountered in our daily life. Those events are created. The time when those events are created is nothing but event time. The time information is provided by the local clock of the device generating the event. Okay, suppose I have used one system. So event time is nothing but the time of that particular system when I have started searching for any website. That is nothing but event time. And event time is nothing but the local clock of the device. Processing time, the time when the event is handled by the stream processing system. After generating the event, the time at which the stream processing systems has handled to process those systems are nothing but processing time. This is the clock of the server running the processing logic. Okay, this is not the clock of the system. This is clock of the server which is going to process my website data. Okay, I have here as a first stage, I have opened my website. So the server, it directly connects to the server and I'll get the proper web page, right? So in the middle there is a link between first window and second window, right? So that is nothing but server. So processing time is nothing but the time of the particular server which is processed my query. Okay, that is nothing but the processing time. These timelines become very important when we need to aggregate the events with respect to another event. Okay, why these events are specially important means with respect to time only we can aggregate those event time and processing time with respect to one event and another event. Okay, this is all about timelines with respect to stream processing. Okay, so the next topic and final topic is that the factor of uncertainty. Okay, what is the uncertainty here and why it is related to stream processing and how we are going to handle that kind of uncertainty. The factor of uncertainty. Okay, in a timeline, data at rest relates to the past. Okay, in a timeline, the data which is at rest, we are referring it as a past data, as I have told you in the previous slide. Okay, data at rest is nothing but the past data. Data in motion can be seen as the present data. Okay, the data which is in motion can be seen as a present data. Then what about the future? Okay, here which means that suppose I have a data types of 3. Okay, one is data at rest, another one is in motion. Suppose I want to add any event to my particular motion data. Okay, this is nothing but future. So how many types of events are going to add to my motion data? What is the time difference, and what are the things I can add to this particular motion data? Okay, so it makes no assumptions on the throughput at which the system receives events. Okay, we cannot tell that how many events it is going to receive in the future. So future is uncertain, right? We cannot calculate and we cannot tell, as a unbounded nature of the data. Here future data is uncertainty. It is a challenging to predict the peak load, yes or no? So with the unbounded nature, we cannot tell that these many events are going to add in the future to our motion data. Okay, so this kind of challenges can handled by the stream processing technology. So here, what is the main definition of stream processing is that dealing with the uncertainty is an important aspect of stream processing. Okay, this is the conclusion of our stream processing technology. Dealing with uncertainty, which is not certain, and we cannot measure the workload of our future events. So dealing with that kind of data or workload is an important aspect of our stream processing technology. Okay, how we are going to do this kind of this kind of processing by using uncertainty of the data, we are going to learn in a coming slides. Thank you so much for your time and attention. Thank you.